So, hi, very good morning to our follower of the Theben webinars. A very good morning to our business partners and our valued colleagues in abroad. So, we like to welcome you to our webinar today. Which means Christopher at the control panel, supporting us like most of the time. Thank you so much in advance. And myself, Elmar, I'm responsible for the technical support and the training. And hopefully we can give you today a reasonably good insight of any kind of, let's say, heating and cooling and ventilation solutions. So for this purpose, we prepared some. So the content of the day is the application settings and the function examples. So later on in the last third of our webinar, we are swapping to the demo panel, and you will see some actions. So a prepared project is there available, and I will introduce you how we did or how I did the setup. So I like to introduce or to make you acquainted with our next following heading webinars. So 15th of March, so we more concentrate on the content of CO2 sensors. So for which purpose, how we can apply, how we can do the setting, and what kind of control we can effect with these CO2 sensors, especially in these days of Corona. And then 26th of March, we do have concentrated more on, let's say, KNX product range, basically. So we have a kind of eagle view on our product range for all such new colleagues or new followers, for instance, who want to update himself. What about the abilities of the Theben group? And 20th of May, we concentrate more on the heating basics. So we start from the scratch. So we start about and talking about, let's say, heating principles and so on. And your desires are required. So that means if you have some special desires for the heading webinars with Theben products, so just share your ideas with us and send it to training/center@theben.de and give us your insight. So what you like to have, what could be probably of your interest, and we will hopefully find a good, reasonable solution for you. Okay, always appreciated your comments. Yes, so room temperature control, what has to be considered, what is, let's say, the principle, what are the basics. So just to give a really rough and a short overview. So this is a standard, let's say, heating principle system. So mostly used here in middle of Europe, so in Far East, Australia and so on. So the heating is not that much required, probably in some specific areas, but mostly then covered with fan coil units, so heating and cooling, for instance. But this is just a principle. But more of interest finally is how many impacts basically we do have inside of a room. So we do have here impacts of, for instance, any kind of lights which are absorbing any kind of warmth. We do have thermal radiation of heating systems, sure. We have thermal radiation of people in a room, inside of a room, and as more people are inside, so we get more warmth in the room. So approximately 100 watts per hour is emitted from a human being with a, let's say, standard working. If you do hard work, so then probably you're giving 200, 300, 400 watts of energy, of heating energy into the room. And we do have some impacts from the ambient situation. So that means the weather and all these things finally, and technical equipment as well, sure, which affects finally the temperature measuring. So this temperature measuring, so this is a control principle finally, the RTR, the room temperature controller. So this controller finally is measuring. So what is the current temperature? Gives a certain, let's say, value to a valve. Depends on if we are talking about a continuous valve, or if we talk about a valve which just is able to give us an I/O command. to open and to close the valve, for instance, and the warm water system. And we do affect finally the radiator, so we open the radiator or we close the radiator finally. And like mentioned, so we do have some impacts in the room, which has a certain impact finally on the measured temperature. So, and this is, let's say, a cycle which permanently runs. So that means permanently the RTR measures how is the current situation affected by some external stuff, and finally this control value, which is sent to the valve, to the radiator, permanently adapts to the requirements. And if you have really smart actuators, nevertheless, if we talk about DIN rail or if we talk about flush-mounted actuators, for instance, and if they are really such powerful like the Theben actuators are, so they can give you the highest actuating value, and with this highest actuating value, we can adjust automatically, full automatically, here the heating curve of an intelligent heating system without your input, without modifying anything. So this is an automatism which runs on his own. But you need powerful actuators, which we do have. Yeah, and finally, in, let's say, in products, it looks like that. Just as an example, we do have here a room temperature controller, the AMUN series, for instance. We do have here a motor-driven valve, which gives us a continuous response and opens in this case, the radiator according to a specific value, so 20%, 25%, however, what is desired. And then again, the impacts, and this circle runs like that. So just to give this control function finally a face, yeah. And yeah, this is just what you need to know. And a second thing, I like to make you acquainted with this finally. So the hydraulic adjustment. For which purpose we need that? Probably you discovered somehow, somewhere in your projects that probably one of these radiators in one room, one of this is warmer, yeah, and the other one, for instance, on the other side is not that warm, but the control command is the same to the valve. And most of this is the mistake of this hydraulic adjustment. So that means this has to be done by the heating specialist, and this finally affects that the water flow inside of this heating or / cooling system is identical. Yeah. So if you have this, one radiator is warmer, the other one is colder. However, you can't adjust with KNX. No single controller in the world can support you in this case. Here, the specialist from the heating has to do this hydraulic adjustment for the heating and cooling. So let's have a look into the, let's say, solution. When we talk about heating, so here heating, I just scratch a little bit. I haven't prepared any, let's say, project or example, for instance, because this is another webinar which we are heading approximately in April or May. And then we just concentrate especially on such kind of solutions. So we do have this heating actuators controlling just, let's say, two-stage valves, so thermal valves, not auditable. And we do have, for instance, here a temperature controller, the RTR, the AMUN. The AMUN is finally this controller here, which I hold currently in the camera. And this AMUN, for instance, is a room temperature controller and a monitor in a certain instant. And like you can see here, so we do have here, as the first company, so far as I know, the option to synchronize the Theben app, the AMUN app, with this room temperature controller, and so you have a remote and to the controller, and you can adjust or call up any kind of functions with the Theben app. And this you will see live at the end of this webinar, so how to synchronize and what you can do. It's a nice tool and full automating running. Yeah, some heating principles, so just stretching a little bit. So you discovered definitively in the one or the other application so this PWM period, and there is a time behind. So, and what does it mean? What is the effect finally? This PWM control, I prepared here an example. For instance, if you have adjusted the 10 minutes, so one step back, so 10 minutes, okay, and if we have here this time frame, so we have here 10 minutes, and if, for instance, the room temperature controller measures, okay, the room temperature is like that, and we need to come to a specific room temperature, so this requires, for instance, 20% of heating value. So that means from these 10 minutes, 2 minutes, the valve is open. Gives us for 2 minutes the warmth into the room and then stops. And depends if the temperature is dropping or if the temperature is increasing. So this time frame adjusts or varies. Okay? So what does it mean if you extend this time frame of 10 minutes to, for instance, 2 hours? From 2 hours, 20%, 40 minutes, okay? So that means we have a longer period. And this, for instance, if you take here a longer time scale, a longer time frame, this is ideal for floor heating, underfloor heating, warm water underfloor heating. Why? Because this, let's say, heating source is slow. And due to that, you need a longer time frame to adjust, to calibrate, and to control. These 10 minutes or 15 minutes, depends, is ideal for radiators. Okay, so just to make you acquainted, so how it works. And if you have some differences, so discovered, so this is a kind of calculation module. So then after a while, so we do have here, we discovered here we need 20%, and then the temperature is dropping, we need 30%, and the next time, so we have a certain calculation internally. So then we open for 50%, so they become rather fast back to our temperature. You have not just to do that. This is an automatism running in the background, in the software of this room temperature controller. So what is basically required? Basically required is more or less, frank speaking, just one control command. Yeah, it is just the heating actuating value from the AMUN, from the room temperature controller in our case, and you have to address the value to the heating actuator, which is adjusted in this case to a continuous control, like here. Yeah. So due to that, we give here a percentage value, yeah, byte value. If you have adjusted, for instance, to switching, so that means it's a typical heating principle for hysteresis control. So what his hysteresis control is I/O, yeah. And there is nothing between, it's just I and O. Continuous mean step open, a further step open, stop, step close, stop. You know, there are positions in between in percentage. And due to that, to bring these to run, it's really rather simple. You have just to connect these two group addresses, and that's it. And all the other things are just, let's say, probably of interest. So as a feedback of the current value, for instance, or a feedback of the set point value, for instance. So for which purpose? So the purpose of these settings, for instance, is to visualize. So if you do have here, for instance, a visualization, if you do have a mobile with a visualization on your mobile, so then you can read, so how is the current situation? Yeah, so can it visualize? We can do as well, for instance, the operation, so the operation mode. So that means we need another communication object. So that means, for instance, if the room temperature controller gets from a time controller the command, so at 10 p.m., p.m., for instance, so decrease the temperature to night mode. So then the operation mode is, let's say, preset, and we bring down the room temperature from 21 degrees to 90 degrees or whatever is, let's say, preset. If a window is opened, so this is another communication object you will see later on in the fan coil actuator application. So if the window is open, so then automatically we turn to frost protection. So for the airing, which is currently really appreciated during this COVID time. Airing, don't forget it. But when the window is open, so then to avoid that, for instance, the heating, the warm air is streaming out through the window, so then the heating system stops for a while. Or the other way around, for instance, if you do have air conditioning and you want to do an airing, however, so then the air conditioning stops as well. So for this case, we need another communication object, and this is basically to be linked to the room temperature controller. But you discover here as well, there is a heating controller inside. So the actuator can be just an actuator requiring the room temperature, and he can be a heating actuator on his own. So that means he just needs to have the room temperature as a value, as a 2-byte value. And with this room temperature, the actuator is do the control management on his own. So that means this puts you in a position, for instance, if you have such kind of a small fancy temperature probe, and with this temperature probe, you tap, for instance, the room temperature, and you give it as a 2-byte value to the actuator. So then the actuator is controlling on his own. Each channel on his own principle, can be an actuator, can be a controller, whatever is required. Important to know or to be considered finally, because from time to time I get from my colleagues in the telephone hotline in the technical support, yeah, the hint, hey, one of these triacs inside is destroyed due to overload, and we had a phone call to the client. So what is the reason? What happens? Yeah, he hasn't used our valves and not considering the inrushes, and due to that we have to consider that 3 of these channels maximum can be linked to 5 valves with 230 volt. Please be careful. Even this is just a simple thermal valve, has a certain inrush at the beginning, so for a couple of 4 or 5 seconds, and after that, so everything is fine, but this first inrush is highly stressed on the inside of the triac, and this can be, for instance, the end of a channel, of a heating channel. So back coming to our main topic of today, so these fan coil control, these heating, cooling and ventilation, which is from the application side highly interesting, especially for hotel applications, for instance, or for industrial purposes, yeah, or for offices, buildings, municipalities and so on, wherever, let's say, a certain degree of technical equipment is available, yeah, or is integrated in the building. And this has to be controlled finally. So the function in principle, so we do have here, let's say, a fresh air filter. So we are hoovering here a fresh air inside with a fan. It is blown through the tubes inside the different rooms and so on. And these fans can be controlled, either I/O, in stage, or stepless. So we support stage and stepless. Yeah, so that means either with the FCA1, we can control 3 stages, and with the FCA2, which is absolutely one of our remarkable fan coil actuators, is giving us 0 to 10 volt output. So to control fan stepless or dampers, for instance, stepless. Big advantage in this case, because if you do have some noises, yeah, through the airflow inside of a room, you have a meeting and you feel a little bit disturbed by that noise. So due to that, so you can probably adjust these fan speed stepless to bring it down a little bit. So you can do it with the app, for instance, on your mobile. You can do it with a controller and on the wall, however. So in stepless solutions, so mostly you have more abilities and more flexibilities, and it's more accurate. Yeah. So we do have what is the advantage of such kind of a fan coil actuator. A fan coil actuator is giving you heating if required, is giving you cooling if required, and sure, the ventilation, so to bring the warm air in or to bring the cold air in or to do the air exchange, yeah, according to CO2, for instance. And the energy efficiency describes definitively that, especially when we talk about, let's say, heating or climatization, however, in the highest degree, we need to have a single room control command and giving us the highest actuating value. So that means we give to the system, to the heating or to the climate system, the highest degree, the highest actuating value to control in the most best way. So in my project, I have specifically used the AMUN to control manually by a manual override my desired room temperature. We do have here the FCA. In my case, I use the FCA2, and I have integrated as well a CO2 sensor, which cares about the air quality, for instance, in a room currently, in order to do some air exchange if required. This damper control I have mentioned, so that means with these damper control we can open here these kind of curtains, air curtains, however in the reasonable way, or just by 3 stages like you discover here. From the appearance, same housing, most of the hardware inside is same. The difference is finally here the output. So we have here 3 outputs for the 3 stages, and we do have here the 0 to 10 volt output to control, for instance, such kind of dampers or thermal valves controlled by 0 to 10 volt. So what we have to consider, especially before we start the setup, we have a certain touch point, and the touch point is finally the heating or the climatization system, heating and cooling. And we need to know if this system is based on a 2-pipe system. 2-pipe system you discover here. So the heating liquid or the cooling liquid is flowing through the same pipe. So that means, just as an example, so the warm water is flowing here in and comes out here and back to the heating source. If we need cooling, so then we definitively need a delay time, and then externally a valve opens and brings in this 2-pipe system the cold air, the cold liquid finally, in order to cool down this air conditioned system, and the flow back is here as well. This is intensive. You have to care about this because this is the preset which you have to do, and according to that you get the reasonable communication objects on the ETS side. The most, let's say, common solution is this way. So that means we do have here a so-called 4-pipe system. So that means we have 1 pipe system which is just for the heating, and we have a 2nd pipe system which is just for the cooling. So this is the most common one. So just that you see the difference, what is this and what is that, and I think this makes it more visible and more better to understand. So that means we have here as well the airing control, but the airing control if we do a forced mode. So we have a conference, many people are in, and we have a fan speed 100%. However, this does not affect any kind of control, neither in the cooling or neither in the heating pipe system. Yeah, it's just controlling that one. So just there is no relation between each other. Yeah, and back again to the valves. And I think it makes sense to have just a glance on that, because this hardware, and if the hardware does not working properly, so then don't expect that the result at the end of the day is quite fine. So due to that, you need to have these some, let's say, simple basics. Thermal valves for the FCA1. You have just to apply on the FCA actuator. That's it. Don't forget the hydraulic adjustment. If some is going wrong, one room is warmer and the other room is colder, but the warm source is same, is equivalent. So have a look on the hydraulic adjustment. This is as well existing in heating and cooling systems. When we go for 0 to 10 volt control, this, let's say, control is a little bit different, a few bit different from the approach of the wiring. So we have to, in this case, we have to apply 24 volt DC. To this valve, we have in this case 3 wires. And then we need to apply the ground and the 0 to 10 volt to the output of the FCA2. So we have here V1, V2, we have here the ground, and this valve for the heating, this valve for the cooling has to be applied once here and ground. This one here and ground, and that's it. And then according to the temperature control command coming from, for instance, from the ionate, so we get the reasonable value, and these 0 to 10 volt valves opens or closes in stages. So this valve is able to stop at a certain degree, to open at a certain degree, to close. The other one, again, so the just simple terminal valve, just able to open, close, that's it. Okay, so just this is hardware, and this is important to know, because if this does not work again, so then don't expect too much at the end of the street. Yeah, let's come to the topic now. So we do have here the FCA as a fan coil actuator. We do have here the room temperature, what has finally to be considered. In my case, in this application for hotels, municipalities and so on, or schools, however, so I have adjusted, for instance, here heating and cooling. So I want to have this heating and cooling support, especially in these hopefully nice summer days which we are heading. So we need cooling as well. So due to that, if we adjust to heating and cooling, so we get here as well the activating value for the heating separate and activating value for the cooling separate, and this has to be supported. So what is required? So from the EON 108, as an example in our case, so we have to adjust in an application setting as well. So we need this EON for the heating, for the cooling, and if done, so the actuator, this EON, this room temperature controller, is sending the activating value, and this has just to be linked to the fan coil actuator, and the cooling activating value has to be linked as well to the cooling of the FCA. So it's, let's say, the minimum what has to be done, and then the system is almost running. Yeah, it's not that big deal. All the other things on top are probably nice to know or required in terms of when it comes to ventilation and so on. When we talk about ventilation, so ventilation means these are stage 1, stage 2, stage 3, in stages or in percent. So it's a matter of the setting. Later on I will open the ETS and show some application settings. And this has to be finally to be activated. So you can do, for instance, this manual mode, forced mode or automatic mode. Forced mode means with the eye you force the fan to start to do a rather fast airing into the room in order to prepare a meeting, that we have a good air condition or the air quality inside of the room, or after a meeting, however. So then full speed, and we can do that. Or we leave it in automatic mode, so it's finally up to you. This can be done, this has not to be done, it's not mandatory. Fan stage forced operation, so that means here this has to be linked if you want any time to override. So that you, as user of the meeting room or the guest in a hotel, for instance, you want to operate manually, you can do the airing on your own, you can adjust however you like it. So this is finally a matter of how comfortable the system or the project is set up finally. You discover here the window stages. So that means if the hotel puts you in the position that you can open the window, so then you can here link, and then when the window is open, then the entire system goes down to frost protection, for instance, so that you do not lose, let's say, the treasure of energy, heating or cooling, however. This is an option. It's not mandatory, but it's an option. Then we do have here a Presense communication object, which is mostly used in our cases when it comes to, let's say, an office or a schoolroom or a meeting room, for instance, just in case if somebody is present for a meeting or a school lesson is getting started. So then finally the Presense sensor tells you somebody is in the room, so now let's start from, for instance, standby mode to comfort mode, or for instance, then consider the airing, however. So that's a matter how you want to integrate it, if you like. The operating mode here, you know, communication object with sending 0, 1, 2, 3. You can change the different, let's say, operating modes. And this you can do by evaluator manually, or you can take, for instance, a powerful time controller, which you do have in our product range, giving you to a specific time, end of the day, municipality is closed, or the office is closed, for instance, latest at, let's say 8 o'clock p.m. or such. So then we send a command, so turn now from comfort mode in general down to night mode or so. So this you can do however you like it. For these exactly, for these purposes, you need these communication objects. The control actuator value is just finally to display. If you are eager to know, if you are eager to see it, for instance, on your mobile, so then you need these communication objects, which has to be linked finally to your visualization. Window contact, here you see, this has to be linked. We have here window contact from the actuator. We do have here the window contact as an info to the EON. So that means the EON finally, our EON displays you with a symbol finally, which you can choose. So the window is currently open. So as a kind of feedback of the system. The window contact, by the way, has to be applied here. We do have here in the E1 these two terminals here. This has to be applied, for instance, to a contact, I/O contact, and if the contact is open, then finally we send a status, and here the display pops up, window open or such. Okay, so in terms of let's say split units or units in the sealing installation, we do have here. So just as a, let's say, idea how it can look like physically. We do have here finally the valves for the warmth, heating or cooling. Yeah, here just one valve is visible, but here, located here, is the other valve. So you open here heating or cooling, however, and here is finally hidden behind the fan, which you can control, depends on the system here from Rosato, from Italy, for instance. So you can control here in the different stages or stageless or stepless in this case. Yeah. So when it comes to when it comes to the Presense control, so the Presense dependent control, in general we use let's say a Presense sensor. And this is a specific webinar which we are heading in the next couple of weeks, specifically with this, let's say, multi-sensor. You can put all in one, not separate a CO2 sensor, separate a Presense sensor. So we have here our multi-sensor, which is here exactly, and here all is in. So we do have here the room temperature, we do have here the CO2 value. We support the Presense function, for instance, and these can be integrated in the heating and cooling system in a school, in a municipality, and so on. So this is the thing. Why I start now with the air quality for a second? Because this air quality is currently highly of interest. It's really in the focus, and we have more or less daily have the touch points, because airing is required. If you do not, let's say, this technical stuff like automatic ventilation and so on, you have to do it manually in order to bring down the CO2 value in a room. And you know, the CO2 is related to these current viruses we are fighting against, and as high the CO2 value in the room is, as high the risk finally is to get infected if somebody is in the room by these viruses. And so due to that, a good ventilation is mandatory. Yeah. So just to give you a figure, so if you, for instance, breathe fresh air, so we talk about roughly 400 ppm, you are breathing in. But if you're exhaling, for instance, so then can be up to maximum 40,000 ppm. In general, I measured it a few times myself, so just doing work like that. So then it comes to around 10,000 ppm, but if you are working quite hard, yeah, so then this exhaled value of carbon dioxide can increase up to maximum about 40,000 ppm. ppm stands for parts per million. It's like lux for brightness. So that means there is a reasonable factor in between. And as well, so the CO2 sensor finally is measuring as well the humidity. And the humidity as well has a certain impact on these, let's say, transportation and effects with this virus. Medical researchers, for instance, confirm currently that especially this specific virus at least is less resistant if the humidity is above 40 to 60%. And the temperature is above 30 degrees. So that means if you have a good room climate, so it's a good, let's say, protection to prevent, in order to prevent, let's say, worst case, to be affected by this current virus. Just to give you here a reasonable, let's say, value so that you can appraise. So what is 40,000 ppm, for instance, or what is 400,000 ppm? So just to make you acquainted, so a natural good air quality is around 400, 500, something like that. Around 1000 ppm, so probably if you are a really sensitive person, so you feel there is, the air is not that fresh anymore, let's say, this way. When it comes to 5000 ppm, so this is from European normative regulations, it's a maximum of concentration in working areas, in working zones. This one I make you acquainted is concentration while exhaling, and 100,000 ppm means it is the extinguishment of a candle on its own. So when we do have 100,000 ppm, so a candle is extinguishing on its own. You know, the people 150 years before, going down in the ground, digging coal or such, or gold, however, they had a candle, and when the candle comes down, they knew exactly, so now the CO2 concentration is too high, so we have to chase away to avoid that, probably we will finally die. And around between 100,000 and 200,000, it depends, it is being mortally for human beings. So that means at that stage, it's a matter of your life, highway to hell or stairway to heaven, I don't know. So, but then definitely it's mortally. Yeah, with the FCA2, we do have here another option as well, so, but this is really high sophisticated, especially for the warmer areas in Far East, in Middle East, for instance, when we need especially the air condition, pretty much more than here in Europe, middle of Europe. So we can make use of an interesting function. So we need external temperature, and with tapping this external temperature, we can do a parallel shift of the indoor temperature control. So as warmer it becomes outside, so the inside temperature is increasing automatically as well. This can be adjusted. So that the difference from the inside to the outside, when you leave finally your office or when you leave the municipality or the schoolroom, however, so the difference is not that big, not that much, so that your body can adopt and can handle it and can manage it finally. This can be adjusted, and this means, for instance, we have here a 2K shift. If we do have here, for instance, starting at 25 degrees, and if the outdoor temperature is increasing for 1K, so the indoor temperature is as well increasing for 1K. So that means the set temperature will automatically adapt to the outside temperature. I think it's a quite interesting function, quite simple. You have just to link finally a temperature probe from the outside, which has to give the physical value of the ambient temperature, and this you have to link finally to the indoor temperature, which is here from the FCA1 or FCA2. The application is widely same, FCA1, FCA2. So and then the automatism is run on its own. You can adjust so from which stage of this temperature this adaptation shall start, and how the degree of this adaptation, if it's just 1K or 2K or 3K, however, it's adjustable, whatever is required and needed. Yeah, this we skip at a moment. Yeah, and then I think it could be of interest when we have a look in the ETS. So because time is running, I got a hint from my colleague. Don't talk too much. So I have here the FCA2, and you see here I've activated here heating and cooling, and I receive finally these two separate communication objects. If I just want to have, for instance, the heating activating, so easy to discover, so then I have here just the communication object. I leave it in heating and cooling because heating and cooling is required, especially for the spots in the around the globe needing, supporting heating and cooling in prestigious projects. And here is the important thing, which has to be set, 2-pipe or 4-pipe. Please just do it before you start with the setup. If you discover later on, after setup, oh shit, sorry, the hardware, the physical hardware on site is not a 4-pipe, it is the 2-pipe, so then you start from the scratch. So first of all, have a look on that. What is the physical touch point from your system, FCA control, to the heating and the cooling system, and then start with the setup. Then we can do, for instance, here adjust remote controller. So that means you require a temperature controller, like in our case the EON 108, or you use an internal controller. And in this case, we need a temperature probe. Yeah, so like for instance, room temperature sensor like that, or in our other EON sensors, we do have here in all products, we do have here inbuilt a room temperature controller, room temperature sensor, for instance. You can make advantage of it and just link it finally to the actuator here. We do have this outer temperature. This is outer temperature, and we do have here, where it is. Here, okay, actuator from support. So this must be exactly that external, this is E1. So and here finally has to be applied the communication, the temperature from the room, for instance. I think these are the most important thing. Then the fan stages. Here is the only, let's say, application difference between FCA1, FCA2. FCA2 gives you the option, puts you in a position, you can decide either or. FCA1 just support stages, so 3 stages. And finally, if the stages, if you have here 0 to 10 volt, then again a percent value if you have in stages, so you can start here, for instance, at a certain degree when stage 1, when stage 2, and so on, further on, is communicating. Okay? You see here, fan stage report 1, 2, 3. And if we go to 0 to 10 volt, then we get just the fan speed mode in percentage value here. Okay, heating valve. So we can adjust here, for instance, specifically, this is fine tuning. If you know the runtime of a valve, fully open, fully closed, then it's quite good. If you can apply here, we put here a default value, which we know at the average from the market. So this makes, let's say, the setup quite interesting. And I want to mention as well, so we do have here inside of the fan coil actuator as well, we do have here so-called auxiliary relay for an additional heating support or for other things like that. So if you want, so you can, for instance, you know, for a second stage of the heating, however, you can adjust however you like it. Drip tray in fan coil systems always required. You know, if you have 2 sources, heating and cooling, so there's a temperature difference, and this causes finally a drip tray. And there is a liquid stage, and if the liquid stage is in the system is exceeding a certain level, a certain degree of level, so then we can finally give a command. So please care about that. Yeah, so just to make you known and further on. So this is exactly the setting which I've mentioned 2 minutes before. So this automatical adaptation to the external temperature. Here you set from which point it shall start finally. yeah? And here you can adjust, for instance, in which steps, in which degree, in K, it changes. Okay, thanks for the hint. Okay, great. So that means we do have here the different operation principles, and we can adjust here as well. So what is finally the mode in the FCA1? So which point we shall reach, and for instance, especially when it comes to let's say Presense dependent control. So what we want to have, just a Presense controller, so that means a Presense sensor, or we want to do it by a key card in a hotel, or with a switch, for instance, however, or a push button. Yeah, so just a short insight on that. This is what has to be considered, and I just open here as the last point the parameters of the RTR. So that means I have here the RTR settings. I have here adjusted as well heating and cooling, so that's the reason why I get here the heating and cooling support. I want to activate the fan stages. You have to do it manually in the application setting, otherwise you do not get supported the communication objects. I chosen here the internal sensor, which is inbuilt in the controller, and if required I can do some adaptation. But I want to make you known, we do have here in our factory, we have here a room, a climatized room, where all our temperature controllers are calibrated, and but if required, so you can adjust on your own, however you like it. Operating mode, so how long it shall last, for instance, can adjust here for conferences or whatever. The heating control, here you have to define specifically if you want to have support of cooling, of continuous control, so that means you send a percentage value or byte values or 2-point I/O. So this is mandatory to preset in advance. And heating set points, here you can limit. I think this could be of interest, especially when it comes to, let's say, projects, public buildings, schools, and so on. You can modify the temperature, for instance, but not from the lower level to the maximum level. So I come in, I put it to 26, my colleague comes in, puts down to 20, the next comes in, puts down to 16. So you can physically limit it, for instance, so the maximum value. For instance, you give the permission, maximum 24 volt is the upper limit. You can press on the push button, okay, but it doesn't affect anything. And the minimum is, for instance, lowest 16 degrees, and that's it. Yeah, so then you can do whatever you like, but in the background, in the software is adjusted where are the limits finally. Cooling control, same stuff, depends on the system. The cooling points you have here definitively to adjust the so-called the dead zone, yeah, dead zone between the heating and the cooling if you have full automated system. So it's not too recommended. For instance, you set, for instance, 21 degrees and exactly on 21 degrees, so then the cooling system starts. So you work two systems, heating and cooling, are permanently working against each other. It's not really efficient. So due to that, I will definitively recommend, so minimum to have about 2K. Depends on the room, depends on the insulation and so on the isolation in such a room. But don't put it too low, and take a value around 2K, then it's fine finally. Yeah, fan stages, you can limit finally if you want. You have just one stage or probably more stage, and you can adjust here the value. You remember I have put it to let's say percentage value, so we send a percentage value to the fan, and whatever the ability of a fan control system finally is in a fan coil actuator, so you can adjust here accordingly, and you set here the thresholds in percent, so at which stage, which degree finally it shall operate. Yeah, so and then I'd like to ask my colleague from the control panel to give me the view to our, let's say, small demonstration. Yeah, I have talked a lot, but I think this background is hopefully for you essentially and important. I want to share some insights with you. And for that purpose, I link now as well my mobile on the system. So I do have here my mobile on my table. Thank you so much. So, and you discover here the Theban EOPlay app. So I do now, okay, operation here directly on the control panel. I think it's, you know how it works, and you can imagine how it works, up, down, fan stage, and so on. You can operate manually. And if you press for a longer time, so I get now the actual value. So the room temperature here in our video studio is 22.5 degrees. And now I like to synchronize my mobile to exactly this product here, the EON 108. What you have to do, you need to have a mobile supporting the Bluetooth communication. You download the app for free. So you get it in the Play Store or the App Store, however, and just press here on the plus. The app is sending a query to the surrounding, so which product is in the, let's say, reception area. We discovered here the EON 108. You just confirm by the hook and press OK. And then the preset project, which is in the EON 108, you get finally mirrored. You discover here now there is a pin code. This pin code I have now to type in, and I'm fully linked in in the RTR, the room temperature controller EON 108. So that means now I'm able to control the system manually. Currently, so the temperature has dropped down because the window has been opened currently. So 21.7 degrees, we have the current set point. We do have currently, there is no light on, no heating, no cooling, no ventilation. So now I try to do that. So I'm increasing the temperature, and after a short while, the heating control command has to start. Okay, you see the light, the heating is lighting up. So then the fan is, the valve is open the heating source because warmth is required for the room. I reduce the temperature. I want to have it more comfortable in the warm summer season. So that means I want to reduce the temperature. So, and after a short while, now the red light should turn off. There is a certain delay time, which makes really sense. And now you discover, okay, the blue light. So that means the output here is giving the control command to the valve, open the pipes, giving us the cooling liquid in the system, and the cooling starts accordingly. I have here the different fan coil control. So the steps 1, 2, 3. Aus means off. Sorry, I left it in German. And automatic mode, I think, is self-explaining. Currently, I do have here, Christopher, please swap a little bit the camera to the CO2 sensor for a second. Sorry. Exactly, thank you so much. So now I give just a certain CO2 on the sensor. So that means I have exhaled extremely. And after a short moment, this green light of the CO2 sensor has turned now to red, affecting now the fan stage here has been started to stage 1. Now the CO2 is measuring again, so is increasing because this measuring stage takes a while. It's a slow process. Then we have stage 2 and now maximum stage, because the red light of the CO2 sensor gives me now the indication. So we are overshooting, exceeding the preset values, and this is an automatism. So that means as more people are in the room, as more the CO2 value is rising, as well as we do have here the blue LED, which gives me feedback as well, so that the humidity is quite high. So if I go now here, so the ppm is currently 5,000 ppm. So with this, under this condition, for instance, the humidity takes a while. Then we have here the option to override, in my case, for instance, the fan coil. We can deactivate heating and cooling, for instance, here at that stage. And if I go back to this automatic mode, we currently have stage 3. Probably I want to have stage 1. You see immediately we have now the manual override, and we move down the fan speed to position 1 manually. So we do the override. If I put it down to automatic mode, after a while it controls again and finally comes back to stage 3. It takes a while. Nevertheless, HVAC mode, anytime I can do, let's say, change to standby mode, or can go to eco mode, or however, anytime I can override manually and have fully, let's say, access to the system. Yeah, that's all from my side. So I tried to make it hopefully interesting for you, to scratch a little bit on some heating principles, some basics. I had make you acquainted with some touch points like, let's say, the fan coil system in principle, so the heating and cooling and the ventilation, what you have to consider. I wanted to share some insights, what you have to consider in terms of, let's say, the setup, what you have to do first. And I made you acquainted as well, so how easy it is finally to synchronize this RTR, for instance, with the TEBEN app to give, for instance, a hotel guest, or to give you as well. Probably you have such a system in your home, in your flat. You give you access to override manually by remote this system. You see how easy it is. Always welcome your participation in one of our next webinars. Question to the dashboard. Any questions which has to be considered, or?
There is one, just let me show it. I will read it.
Okay.
In FCA2, there is an auxiliary output, but this output doesn't have any status object. How can I get feedback from this object?
Okay. That's indeed, that's auxiliary relay, just a switching control. Let's open it again. So we do have here this as the application, parameter auxiliary relay via object. So if heating is required together with heating and cooling via object, we want to do it. Auxiliary relay is here. So I just have no feedback. That's right. Yeah. So in this case. Yeah, in this case, we don't have any options directly. With a certain workaround, probably yes, but directly from the auxiliary relay, we do not have.
Probably you can read that object.
Read with
read command.
Just with a workaround, probably, yeah. Read command, probably depends on. We have to care about the flags and so on. But there is no, indeed, there is no direct communication object feedback. How is the status here? I have to say, sorry, okay. I think this is the only blind spot this actuator finally has. Yeah, all the other values are really remarkable. And the 0 to 10 volt, you hardly will find in the market. Okay, thanks so much. So we close at that point. So we have 1 hour, which was prepared for this webinar. If you have further questions, so don't hesitate, come back to us, service/center@teben.de. I'd like to say thank you for participation, and we'd like to welcome you as TEBEN follower and partner and friends in abroad to one of our next webinars heading in the next couple of days, couple of weeks. Thanks for participation. Bye.